This film is about the sun and clouds and warm waters of the Pacific. We're in the central Pacific, almost on the equator, on remote Manus Island in Papua New Guinea and on the island of Nauru. The work these Pacific Islanders are doing will hopefully provide us with a better and improved understanding of how the global climate will change in the future. Extreme weather events cause destruction around the world every year. Billions of dollars are spent fixing up after cyclones, flooding, and droughts. Scientists agree that the world's climate is slowly changing, but nobody knows how much or how fast the climate will change. The United States government, through the Department of Energy, is trying to find out.
The ARM program is part of the United States contribution to the World Climate Research Program. It's a Department of Energy program, and the focus of the program is to ultimately improve models that are used for climate prediction. To do that, we need a data set that is representative of the Earth. The tropics represent a very large percentage of the total Earth's surface, and so this particular area, including the tropical warm pool, is particularly important.
American scientists are working together with the governments of Papua New Guinea and Nauru on a sophisticated research project called the Atmospheric Radiation Measurement, or ARM, program. They study the clouds and what happens to the energy that comes to us from the sun.
The ARM program originally set out to do 5 sites around the planet to try to capture different climatic regimes and different cloud regimes. The tropical Western Pacific was selected because the sea surface temperatures in this region are the warmest they are anywhere in the planet. And this produces a lot of energy and water vapor to the atmosphere, which results in huge cloud systems. And so we're here to study those clouds and also to study the interaction of this with the climate and the rest of the planet.
Most of us would just call it sunshine, but scientists call it solar radiation. It is energy given off by the sun, which comes to us in the form of light and heat. Some solar radiation never reaches the Earth. Clouds high in the atmosphere act like a reflector, and some of the radiation is sent back out into space. A small portion of solar radiation is reflected away from Earth by the atmosphere itself. And part of the energy coming from the sun is absorbed by clouds and by the atmosphere. This means the energy is heating up the air and the clouds themselves. Just over half of the solar radiation reaches the Earth's surface. Most of this radiation, or energy, is absorbed at the surface.
We're basically talking about solar radiation, what comes from the sun to the Earth, and the re-radiation of heat from the Earth back up into the atmosphere and ultimately lost to space. And it is this radiation transfer that is ultimately important to the energy balance of the atmosphere.
The ground and the sea surface warm up with absorption of solar radiation. The shimmering near the surface is caused by air being heated by the hot ground. The hot surface gives off energy. This is called terrestrial radiation. Some of that heat escapes through the atmosphere and into space. This helps cool down the Earth's surface and the air we live in. Terrestrial radiation continues round the clock. Even in the middle of the night, heat energy is given off by the surface of the planet. These images were shot around midnight in Nauru as an aircraft was landing. The flickering seen in the runway lights and the reflection of the plane's lights on the runway indicates that the surface is still warmer than the air and that energy is being lost into space. So, how much of this heat will escape into space? This depends to a high degree on the clouds. On a cloudy night, it is often warmer because terrestrial radiation is reflected back to Earth. On the other hand, if there are no clouds, the terrestrial radiation can escape into space and the night will be cool. It's just like putting on an extra blanket during a cool night. More blankets and our body loses less heat and keeps warmer. More clouds in the sky and less heat can escape into space.
The goal of the ARM program is to try to determine the effects of clouds on the radiation balance of the Earth, and that will be used in these large computer models that are used to predict global climate change. One of the toughest things to predict is the role of clouds and water vapor in the atmosphere on the incoming solar radiation and the outgoing terrestrial radiation. And so our stations are to collect long-term data on which the modelers can use to compare their models to actual data that's taken on the effects of clouds and water vapor on the energy budget of the Earth.
The warm water of the Central Pacific is called the warm pool, or the firebox of the climate system by climate scientists. Satellite images clearly show this area of warm water. The orange color indicates where the warmest water is. The warmer the water, the more evaporation from the ocean surface, the more clouds.
This area has, on average, the warmest sea surface temperatures on the globe. And it's been likened to what's called a boiling pot, or we call it the warm pool region. And it's like a giant heat engine. It's a driver of global climate.
The scientists have found that the warm pool in the Central Pacific affects climate conditions worldwide. They have discovered that the El Niño effect begins here, when the hot surface water moves further east than normal. The last El Niño, in 1998, caused problems worldwide. In the Pacific, El Niño often means we have more cyclones. It causes drought and flooding, and affects the fishing grounds around our islands. Manus Island in Papua New Guinea is situated about 220 kilometers south of the equator, far away from the mainland. The atmospheric radiation and cloud station is located next to Momoti Airport and operated locally by Papua New Guinea's National Weather Service. The site is made up of a number of instruments and computer vans controlling and monitoring a whole range of sophisticated field instruments. Mary John is an observer with Papua New Guinea's National Weather Service, currently working at the ARM site in Manus.
This one is the dry bulb thermometer. This one is the wet bulb thermometer.
Checking the traditional meteorological instruments is only a small part of the job here. Meteorological balloons are sent up twice a day. They provide information about winds, temperatures, and humidity up to almost 30 kilometers above the surface. A small sensor measures temperature, humidity, and pressure. A radio transmitter sends a signal back to the site where the data is recorded and stored. The sonde also transmits its exact position back to the site. The data are not only used by ARM scientists for climate research, upper air observations are also critical for safety of airlines traveling in the Pacific region.
It's been almost 6 minutes now that the balloon has been released, and at whatever level it is at the moment, that is the pressure it is showing. And that's the temperature, and this is the relative humidity. That's what it senses and transmits back and is recorded here. So I just leave these and go on with doing whatever I do usually, and then check it every now and then until the flight is over. The balloon bursts, that's when the flight is over.
Elsewhere in the Pacific, at exactly the same time, Megan Aliklik goes about her job of launching a balloon from the ARM site in Nauru. Where Manus is a fairly large island, Nauru is just a small dot in the huge ocean. The Nauru ARM site is located on the western side of the island and has been in operation since late 1998. This site has the same scientific instruments as Manus, and Megan is one of the local observers. Observing weather is a 24-hour operation.
We have shift work, so maybe I work today in the morning, so I don't work in the afternoon, but I come back after for balloon launching at nighttime.
In Nauru, the balloons are filled with hydrogen. This is cheaper than helium, but because of the danger of explosion, the observer cannot fill the balloon by hand or be near the balloon. Therefore, a remote launching system has been installed.
I'll come in, prepare myself for balloon launching, fill up balloon, and then launch.
The night launch of balloons is just as important. This balloon was fitted with a light, so it is easier to follow with the camera. Inside the computer van, the data is received and checked by Megan. The stations are constantly being improved and developed.
We're going to try to get some trenches put in here so we can put in a water line, a power line, and then the hydrogen gas line for launching balloons.
In Manus, they're preparing to install a remote balloon launcher similar to the one in Nauru. A variety of instruments on the site collect information about clouds. How much of the sky is covered by cloud? How low or high is the cloud, and what type of cloud is it? How much water does the cloud hold? How much of the sun's radiation does it block out? The scientists need answers to these and other questions to fully understand the significance of clouds in the global climate system.
This instrument is called the WSI, the All Sky Imager.
Every 10 minutes, the camera inside the instrument takes a new picture of the sky. The specially designed so-called fisheye lens enables the camera to see the whole sky all around the horizon. Inside the van, a purpose-built computer displays the current picture of the sky and clouds.
This is the picture taken by the WSI, and as you can see, there is Mary, myself, and the cameraman. For this shot, we were able to be on the screen because we were next to the WSI camera. In the next few seconds, we will see another image. The cameraman, myself, and Mary will no longer be there. As you can see, this is what happened after 10 minutes. These are clouds, those are a couple of instruments. Myself, Mary, and the cameraman no longer are there.
The images are stored on computer and uplinked to the researchers in the United States. Another instrument used to look at clouds is the ceilometer. Its function is to constantly measure the bottom altitude of the clouds. It sends a laser beam straight up into the sky and then measures how long it takes for the laser to be reflected back. Computers store the data and produce graphic timeline images of the clouds during the day and night. The microwave water vapor radiometer also looks into the sky.
It measures water vapor and water droplets.
The measurements are taken from the surface to the top of the atmosphere. We often say it is humid in tropical countries. This is because there's a lot of water vapor in the air. For every square meter of land and sea in the tropics, there is approximately 60 liters of water vapor in the air, something like 4 buckets of water. This is about 60,000 tons of pure water per square kilometer of islands and ocean, almost 20 times the capacity of this fuel tanker. Yet we can't even see it because it is spread so thinly out between the Earth's surface and high in the atmosphere. Water vapor is a very important factor in climate research because it absorbs both solar and terrestrial radiation. A whole series of instruments detect solar radiation.
This instrument is called the PSP. This one actually measures all the radiation that comes from the sky. Total radiation that comes from the sky. If it's cloudy, then there's not so much radiation coming through. This particular instrument measures all that. This instrument over here is the PIR. It measures the heat radiation that comes from the sun. This instrument here is the UVB, the ultraviolet biometer. It measures the ultraviolet rays that come from the sun.
Another instrument measures radiation from the whole sky except the sun. 2 small shades block direct sunlight from getting to the sensors. This instrument, on the other hand, looks only at the sun.
It measures radiation directly from the sun. It's pointed directly at the sun and measures whatever radiation that comes straight from the sun on it.
A series of similar instruments look down on the ground, measuring reflection and radiation from the surface. The ARM program is not only doing research in the tropical Western Pacific. There is another ARM climate research station in the Arctic, under freezing conditions in Alaska. The same instruments are in operation, measuring clouds and radiation in the Arctic region. The biggest research station is in the southern Great Plains of the United States, where instruments have been spread out over 40,000 square kilometers. The ARM project activities in the Pacific are carried out in collaboration with the South Pacific Regional Environment Program, SPREP.
The South Pacific Regional Environment Program has been given a mandate by the 26 of its member countries to coordinate and facilitate all the climate change and climate activities, and of course meteorological services activities in the tropical Western Pacific. So we've been involved in ensuring that the program not only meets the goals and objectives that are set out under the ARM program for their own needs, but also meets the needs of individual countries, SPREP member countries that are involved in the program.
ARM is making an important contribution to the weather forecasting services in the region.
Currently, this ARM site is providing the National Weather Service with the upper air observations, and this is the only upper air observation stations in the region or in this part of the world, apart from the other sites that are not operational at the moment. So the data that we receive through this site assist our weather forecasters in doing weather forecasts.
In addition, we're just putting up the forecast now this week for the first time for the people of Nauru, which was not available before. So you can see a lot of the benefits directly to the people of what this sort of program is all about.
The ARM program has also helped with the development of a new school curriculum about climate change and held workshops for teachers in both Papua New Guinea and Nauru.
The students need to know, about issues that affect their lives, and with the climate change, and the sea level rise, it's very relevant to their needs here on Nauru, because we have experience going through these droughts and the El Nino effect.
Cooperation with local authorities has been essential for the successful operation of the ARM sites.
We're here at this site in Nauru because of the interest of the Nauruan government, the Nauruan people, and we have found a very receptive attitude virtually every place that we go in the Pacific to help us make our measurement program successful. And without the cooperation of these island nations, we could not be successful here. And it has been really a great experience.
The whole project has been very beneficial to Nauru. It has been my intention, and my government intention, to develop our people, especially in terms of technology areas, and which we are very lacking at this stage. And the development of our National Weather Service is part of it. And the international recognition that the ARM has given us is another factor. And I'm very, very pleased with the project. Now it is progressing so far, and assistance rendered by the locals and also by the ARM management team to get this project up and going.
JNSR, this is Nauru Operations. Just wanted to make sure that both of you and the Ron Brown received...
In July 1999, the ARM program conducted a special experiment in the area around Nauru. More than 50 scientists participated from the United States, Japan, Australia, and Germany, working on research ships, aircraft, and on the island. The purpose of this exercise, called Nauru 99, was to find out if Nauru's landmass affects the research results, and if so, how.
As you know, this part of the world is mostly water, and we're making our measurements over the land. And so we need comparisons of measurements that are made out of the open ocean to what we're making, so we can relate that to the real regime here, which is ocean-atmosphere interactions. So one of the main purposes of this study is to compare measurements made out of the open ocean by ships to those made on the land.
The United States NOAA research ship, the Ron Brown, was part of the experiment. The ship was at first stationed 200 kilometers from Nauru, far away from any landmass, and later moved closer to the island. Many sophisticated instruments were used to study the clouds, the sun, the air, and the ocean. A German team used a specially built laser instrument the size of a small house to detect water vapor in the atmosphere above the ocean.
If you have the sea with the water in, and the water vapor is evaporating and it gets up to a level where the temperature gets low enough that cloud droplets can form. So we would like to look at how the distribution of the water vapor is in the atmosphere, because then you can also see where clouds can form.
Scientists were measuring sea surface temperatures with very sensitive equipment. Satellite experts were comparing data from satellites above the Pacific with measurements on the ship.
Well, the satellite overpass, depending on which one it is, they measured similar things, so we can use their data and our data to compare and see how whether our measurements are good or not.
You've got a satellite up there right now?
Yeah, there's one that passed about 10 minutes ago, and it should probably be in view for another 5 or 6.
Every 3 hours, a balloon was launched, collecting information about wind, temperature, and humidity high above the ship.
Well, this is an extremely important part of the world for weather and climate. A lot of solar energy comes in here, and we like to think of this as a heat engine that redistributes that energy all over the world, all over the globe. And we're here to study how that engine works. The fuel, obviously, is the solar energy coming in, but the ocean itself is a large reservoir of energy, and there are many other ingredients to this fuel.
The Japanese ship, the Mirai, one of the largest research ships in the world, conducted the same experiments in another location, exactly on the equator.
We are trying to figure out what's a part of how much we can have a heat exchange between the ocean and the air. This plot is showing some fluctuations of wind speed and also temperature and water vapor fluctuations. From those data, we can just calculate how much the heat exchange occurred at the boundary layer in this area. And there is a huge amount of heat energy exchange in the western part of the ocean.
The Japanese also took seawater samples and measured ocean temperature, salinity, and oxygen content at depths down to 1,000 meters every 3 hours, day and night.
This is the vertical profiles of the sea. This green indicates the temperature, and this red one indicates you will see salinity. And also, pink line indicates dissolved oxygen. This is very typical because in the equatorial ocean, they show the well-mixed layer here, and drop off dramatically. So, and also, salinity has a maximum around the 200 meters or so. Scientists are now analyzing the data from ships, aircraft, and land-based instruments in laboratories around the world. World climate has changed throughout history. There have been ice ages and warm periods coming and going in natural cycles. Today, though, scientists believe some changes in the climate are the result of human activities over the last 2 centuries. Industrialization and increased populations have caused more greenhouse gases to be present in the atmosphere. Carbon dioxide, or CO2, is one of the most important greenhouse gases. CO2 is produced in vast quantities by energy generation based on fossil fuels, such as oil, coal, and gas,
and by the use of petrol and diesel in the transportation sector throughout the world. For the first time in human history, the Earth's climate may change and sea levels rise as a direct result of human activities. Scientists believe our planet is getting warmer, and it's expected to continue to change in the future. However, there is still a lot we do not know about the climate system. The ARM project will assist us to better understand the complex natural processes driving our daily weather and climate. The work these scientists and local observers are doing every day here in the Pacific will help us better understand how the climate is changing. This will enable countries in the Pacific and around the world to better prepare for the future.
It's a